Our lab's interested in how chemicals found in the environment interact with the endocrine system and affect physiology. We're specifically interested in finding out if exposure to these compounds, particularly during critical windows of development, influences the timing of puberty, because puberty in girls is getting earlier and earlier. Average age of pubertal onset now in the US is 9.5. One of the chemicals that we're interested in is bisphenol A. It's abbreviated BPA. You may have seen water bottles at the grocery store or the sports store with a big sticker on it that says BPA free. That's the chemical that it's discussing. It was commonly used in polycarbonate plastics. It's been phased out for a lot of products in the United States, but it's still used in epoxy resins that line the inside of metal cans, like a soup can or a soda can. And it leaches into the contents, and then we eat it and we get exposed. As part of this work, we've formed a new partnership with the Food and Drug Administration. So the Food and Drug Administration is about to start a new risk assessment for BPA. So these will be a series of studies designed to specifically ask the question, does exposure to BPA pose a human health risk? They have to do a specific set of experiments in order to address that question. And they've partnered with 12 other labs, these are all NIH-funded labs, to address an even greater series of questions to look at mechanism and other organ and tissue systems they don't typically look at. So our lab is one of those labs. And so we will be assessing a suite of behaviors in these animals, and we'll be also looking at brain development within these animals. And we're specifically looking for whether or not BPA is influencing sex differences within the brain, and that maybe those sex differences are underlying some of the behavioral and physiological changes that we see. So the questions that we're interested in are really sort of getting at this concept of the fetal basis of adult disease. The idea that something that happened to you in the womb or right after you're born is going to set you up for disease risk later. This is a new field of research. It's sort of a new way of thinking about how prenatal exposures could subsequently translate into health outcomes later. The only way that we can do this is to use an animal model. Obviously, it would be unethical to expose a woman, a pregnant woman, to BPA and then wait and see what happens to her child. It'd be unethical. It would also take way too long to finish that experiment. So we have to use animal models to do this. We can't really model it with computer models or cell culture models or things like that. So we do most of our work in rats, we do some in mice, and we have new projects now with prairie voles. Endocrine disruption features into sustainability in multiple ways, particularly compounds that are leaching out of plastics. One is we're getting exposed to these different chemicals, and so there's a whole soup of chemicals inside of our bodies now, and we know very little about what they're doing. They might be inert, they might do nothing, or they might be impacting our health, and we need to understand that much more clearly than we do now. The other aspect is that plastics are made from petroleum products. And so if we're talking about energy independence and getting away from foreign oil, one way to do that would be to reduce our dependence on plastics. They also don't break down in the environment, so the vast majority of them end up in the ocean, and we now know that all of the great gyres in the ocean, especially the Great Pacific Gyre, is contaminated with these plastics, and will be for many hundreds of years to come. Nearly all of the projects that we have going on in the lab right now involve researchers at multiple institutions. All of our work is funded by the NIH, and they provide a good conduit to find new collaborators and new colleagues with whom we can work. My pie in the sky dream for how our work will affect the public at large is to come up with new strategies for testing these chemicals. And I think the partnership we have with the FDA will certainly help us do that, to identify other chemicals, not just BPA, that may be causing adverse human health effects.